First wave, not so strong, climbing on the slope, and the water is receding. Second wave, more strong. The second wave is usually the strongest wave, and receding after that of this wave, receding here, and then a third wave, receding, fourth wave, and so on. This is the first case on steep slope. On gentle slope or very flat coast, like in Banda Aceh or in Sendai in Japan, the topography of the shore is very flat. So we have, it was like that in Banda Aceh. The first wave, it's not a very strong wave, began to recede. And after that, we have the second wave, and the third, and the fourth, and so on. And the water pushed inland during maybe 45 minutes. And after that, you have a very strong and unique backwash. So depending of the situation, you will not have the same recording in the sediments. So let's look at the sedimentary signature in the two cases. Of course, the nature of the coast is important too. A tsunami can mark or sign its passage only with the material it can collect on the shore. If you have a very few material, like on rocky coast, you have quite no signature. You cannot say, here there was 1 or 2 or 3 tsunami by the past, because you have nothing to mark this occurrence of a tsunami. The only thing you can see ashore is like that. You have these blocks, and you have a kind of imbrication of these blocks. All are oriented like that, with the long axis like that. And this is supposed to tell us that there was something very strong, a very strong event occurred on this coast. Let's look at another case. We are on the Canaria Islands in the Atlantic Ocean, near the coast of Africa here. And this is the Canaria Island. It's an archipelago, and we have a lot of islands. We are working on this zone here, and on a tsunami event, very old, and on the deposit of this tsunami ashore. This is the general topography of the west coast of the island of Gran Canaria. And all these points correspond to some deposit, tsunami deposit, very strong material. It's a kind of conglomerate, accumulation of pebbles with sand and shells. And we have a lot. Always, like, we have patches on the slopes, very high, sometimes 200 meters, more than 200 meters above the sea level. And the material looks like that. You have here clearly this conglomerate here. And the material is looking at this. What you see here, it's very rounded pebbles, and this cannot come from inland, because these material you can find on the seashore, and they are rounded because of the work of the water and the waves every day. And so the material is not coming from the river, it's impossible, it's coming from the sea. And the material here correspond to sandy material with shells, broken shells, never in live position, pieces of coral and so on. You have here the base of the deposit, and the top, more fine sediments here, and the top is eroding the surface of the first layer. So it corresponds. We have patches of conglomerates, no sign of terraces, and no geomorphological evidence of a marine morphology in the valley. So it could be an old terrace, marine terrace, but it's not the case here. The material is from gravel beaches, and the thickness of the deposit and the roundness and size of the material decreases with altitude. So near shore, the material is coarse, and far from the shore, it's more small. This is due to the water energy decreasing when going upslope. And we have an increasing of the bioclast content with altitude. Why? Because the material is not very dense and float at the surface of the water, and so because of the turbulence, and so it is deposited only when the water is has a very weak energy. We have all the characteristic of a single very strong energy event along this coast. This is an outcrop, and you have the topography before this material is deposited. You have a soil, and the soil, some piece of soil are detached, and you can see some clast collected here at the base. And you have very coarse material here, and a second layer here, more fine, with some lamination, and the imbrication, the orientation, general orientation, what we call the fabric of the material, is attesting a movement from the sea to the land. And here it is the reverse. So the organization of the material is like that and showing a movement to the sea. So this corresponds, the first layer corresponds to an uprush deposit when the water comes inland. We have a progressive loss of energy. So the more you climb, the less the size of the material is because of the decreasing of energy. And at the top, you have the backwash deposit. This is very classical for a tsunami deposit, but only because of the velocity of the water decreasing, all the material at the base of the slope are removed by the backwash, because the energy of the backwash is strong, coming back to the sea, and all the material is erased. So you can see you can find only deposit at a very high position where the energy is too low to remove the material and bring it down to the sea. This is a very frequent phenomenon on the slope of active volcanoes. We have collapse, sector collapse on the volcanoes, and you can see this deposit of rock slide avalanches corresponding to this volcanic flank collapse or volcano flank collapse. And we have a lot in the Canaria. And we are working here on this coast, and the material here, the wave here that have brought all this material on the slope is coming from an event here on the island of Tenerife, and this is the Guimar flank collapse, very well known, and it's more than 145 cubic kilometers of rocks that slide down very quickly in the sea. 800,000 years before. And you can imagine the energy that pushed the water of the sea. And so the water climbed on the slope of, on the other side of the channel here, climb on the slopes here, more than 300 meters above the sea level. So it's a very, very strong event. I cannot imagine if an event like that occurred today, it would be very, very dramatic, because by the past, there was nobody living here. But now, with the increase of the tourism, we have all the coasts are built everywhere. So you have thousands and thousands of people living there. So this could be very terrific. Here you can see the scar of where the slide occurred. And you have the distance between Tenerife Island and the scar here, and the coast of Canaria, and where we have the recordings of this tsunami. On sandy coast, it's more easy, and the signature of the tsunami are more complete. This means that you have seen on the Canaria, on steep slopes, we have only 2 layers, an uprush phase and a backwash phase. And all the rest of if there were 2 or 3 or 5 waves, we have only the recording of the strongest wave. But on a very flat sandy coast, sometimes we have more interesting sedimentary signature. We will focus our study on Banda Aceh, and the city of Banda Aceh is here, and we are here along the coast, at the northeast part of this coast of Banda Aceh. You can see the coast before here, and the coast after the flooding. And we worked along a transect here. You can see the points. And we have worked here. And what we have seen is very interesting. Is, of course, we dug in the material, in the sedimentary deposit, and we can find some layers corresponding to tsunami. The deposit of the tsunami of 2004 event is here. This is the soil of the rice field before the tsunami. And below, we have a very thick sandy material, sandy layer. It's an old tsunami deposit. So we can find at a single place different tsunami recording superimposed, and we will see this a little bit later. What are the specific characteristics of a tsunami deposit? The material display finding upward sequences. The thickness of the deposit decreases landward. It's like in the Canaria, when the deposit is very thick near shore, and then it decreases landward because the energy of the water is decreasing. The size of the material decreases upward. The first waves are more energetic, so you have coarser material, and the last waves are less energetic, so we have finer material. This is logical. The size of the material decreases landward. It's due to the decreasing of the velocity of the water and the energy of the water. Are these characteristics sufficient to link the seas to tsunami signature? The answer is no, because the shuttle movement of the water is the same for huge storm, for instance. So you cannot really say it's tsunami or it's big storm, huge storm. Sometimes you can have the same signature. But when you have tsunami, you have extreme energy, not like with storm. And this extreme energy is able to collect at the base, like I show you in the Canaria, pieces of soil included at the base of the deposit of the tsunami. And this is the case. This is on the coast of Banda Aceh. And you can see that you have what we call rip-up. It's material from the, this was in some, feeding basins for shrimps or for fish. And this was the clay at the base of this basin. And the energy of the tsunami is able to collect this material, and you can find this rip-up at the base of the tsunami deposit. In the stone deposit, you never have this because the energy is not strong enough. So you can have a possibility to differentiate storm deposit and tsunami deposit. Here is in Banda Aceh, but on the south coast of the city of Banda Aceh, we have this. It's a rip-up. You can see more than 20 centimeters in size. Sometimes it's very huge. And you can see from the rice field soil, these rip-up are disconnected and collected from the base. This is very typical from tsunami deposit. So we have worked in Banda Aceh, and it was interesting for us because before the 2004 tsunami event, we didn't know too much about tsunami deposit and about tsunami signature. But here we had a possibility to link the recording, so the sedimentary signature, to the description of the event. Because usually you arrive in a place, you know that was a tsunami, you have a deposit, but you don't know, you cannot link this recording and the characteristic of the recording with the characteristic of the tsunami, because we don't know nothing about the tsunami deposit, the tsunami characteristic. Here we had oral testimonies and people saying to us, yes, there was 12 waves or 11 waves. And so from this, you have the general characteristic of the event, and you can compare this characteristic to the characteristic of the tsunami deposit. The idea is to reconstruct events from the deposit. So in Banda Aceh, we have a lot of evidence of the behavior of the tsunami, of course. From field evidence, this is from helicopter, and you see the orientations of the trunks that show clearly the direction of the waves. We have oral testimonies. We have done a lot of interview with the population and collect a lot of information just to compare the characteristic of the tsunami and after that to the sedimentary signature. In this zone, we had at least 10 waves oriented mainly to sector southeast. The first wave was 1 to 2 meters in height. The second, 13 to 15 meters. It was on the coast just near the city of Banda Aceh. On the southern coast, it was 34 meters in height. The following wave were characterized by an acceleration of the water. And there was no receding, no backwash. Only the first wave began to flow back. The following wave pushed landward during 45 minutes. And after that, we have the main backwash. At the beginning, the water recede very slowly, and the velocity increased towards the sea. So now we can look at the sedimentary signature. We have three zones. What we call the proximal zone is very near to the sea. Then the median zone, then the distal zone is far from the sea. In the proximal zone, the wave energy was very strong. So if the energy is strong, you have no deposit, you have only transport or erosion. So the signature is probably due to the last waves. And when there is a backwash, the backwash is slow inland, but very quick near shore. So you don't have deposit. So the signature here is probably due to the last wave. Sorry, excuse me. In the middle zone, the water energy is lower. The deposit of the first wave is probably erased by the second and strongest wave. And the high energy of the backwash erased the last deposit sequences. So here, this is in the middle zone. So depending of where you are to investigate your tsunami deposit, for the same event, you will not have the same sedimentary recording. The characteristics of the deposit are not the same. In the distal zone, the water energy is low or very low. The second and the following wave are recorded, except the less energy, except the less energetic waves, sorry, here, except these waves, because they are not so strong to reach this zone very far. The backwash, very low in this zone. And the energy of the water is not sufficient to remove the deposit. And the best recording occurred in the depression in topographic lows, like shrimp basins, like old lagunas. This is an interesting place to have sediment recordings. So proximal zone here, median zone, distal zone. And you can see that for the same event, in the proximal zone, we have something with quite no differentiation. In the median zone, we have coarse material here and very fine at top. It's a recording of one wave. Then we have the recording of the second wave here, coarse at the base, and then fine when the energy. This is the front of the wave. Just after the front, we have very strong energy. So a lot of material is in suspension. And as soon as the front passed, you have deposition of this material, this coarse material. And after that, you have the tail of the wave, and you have very fine material deposition. And again, another wave. So you have here more than one and a half kilometers inland. You have 3 waves recorded. And if you are far, you have more than 2 kilometers from the sea, you have 5 waves recorded. This was, the maximum was 7. In one place, we found 7 waves recorded. So you see that depending on the choice of the place you are investigating for sediment is very important. You need to be far from the sea, but not too far, because after that you have the tsunami was not going 3 or 4 kilometers. So here you cannot find, maybe you find only the deposit of the main wave, a thin layer, but you have to find the optimal place to work on tsunami deposit. This is very important. So when we want to work on tsunami, we have a toolbox, of course, and we use grain size analysis, quartz morphoscopy, the morphoscopy of the sand grains, mineralogy, imbrication, sorry, for large clays, clast, and for small particles, then bioclast, and then heavy minerals. I will focus only on two or three analyses. So first, grain size analysis is interesting for us because you can see you have 2 curves. It's a cumulative curve, and you can see that you have here, you have the domain of the silts. Here you have of the clay, sorry, the silt here, and here the sand. And you can see that you have clay, you have silt, and you have sand. So all the material, fine and coarse, was deposited in the same time. This is due sometimes when you have a wave transporting material, when the energy drops very strongly, all the material is deposited together. This is the process that leads to this deposit. Here you have a transport by the water, but the energy is decreasing very slowly, and so you have only the material here, only sand material and coarse sand, especially. Coarser is here and finer is here. And you can see that the total part of the sand are deposited with the same grain size characteristic. So you have, yes, this reflects an energy decreasing very, very slowly. Then with this characteristic of grain size, you can work on the deposit. I show you just before, coarse material, fine material. This is one wave, coarse material, fine material, and so on. And you can see we have coarse material, you can see here. And then at top, fine, coarse, fine, coarse, fine, coarse, fine. And the general size of the material, sorry, is decreasing here at top. This is something we can use. It's a diagram built by a guy whose name is Pasega diagram, and you can put the 5th percentile of the grain size and the median here, and you can see that here you have the base of the tsunami deposit, very, very strong energy, and then here you move slowly to the uniform suspension. This is top of the material. So the energy, you can see the energy is decreasing here. This shows that the energy was very strong at the beginning and very low at the end of the tsunami. Morphoscopy is a work we used to do on grain of sand, and it can bring you a lot of information. For instance, in Banda Aceh, the dunes, there was dunes, a field dune on the seafront, and the material of the deposit was quite only sand from the dunes, to my point of view. But some researchers say, no, 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 the sand is coming 200 meters below the sea level. I say, no, no way, it's impossible. They say, but what are your arguments? So I say, if I have sand from the dune, the surface is very dull, you know, it's not very smooth, it's dull because it's not, it was formed by the water first, but then the wind blows this sand and the surface is not glossy. But on the grain we found, the surface was medium glossy, and in the concave zone, it was dull. So this means that it was a sand coming from the dune that have been transported during a short time with water that polished the grain and shows that all the sand was coming from the dune. So the morphoscopy is sometimes very useful and can bring you a lot of information. After that, we work on the imbrication of the material. You know, if you have a stone, I have nothing here looking like a stone, but if you have a pebble, you see this pebble here. They are very flat. Maybe I have another picture. Yes, you see the pebbles very flat. And so if you have a current transporting the pebbles, the flat pebbles, when the material is deposited, if you have a flow coming like that, the pebbles will be imbricated like that. Like tiles on the roof, this is due, the shingling, the imbrication is due to the fact that the pebble is rolling on the bottom and is blocked like that. In this position, he offers no possibility to the water to remove him. This is the best position to stay on the bottom. So if you measure this angle, you can, and the direction of the main axis, you can retrieve the flow direction. It's very, very interesting. So coming here, you can see that all the pebbles from this formation has one single direction. We have more than 100 measurements on the pebbles, and we can see that we have one single direction. So we can see, and we can say that the flow was coming from here and going to this direction. This is really easy on large pebbles. But if you have sand or silts, it's so small, you cannot find, even if the shape of the grain of sand are sometimes reflecting the same shape as the pebbles, you cannot find this imbrication. It's very hard to do. I switch this. This was a reconstruction of flow direction also. I switch. Our problem is how to evidence the direction of the flow with sand and silts. Because if we can retrieve the flow direction, retrieving first what we call the imbrication is a fabric of a sediment. It's a preferential organization of the long axis of the material. If you can find this, you can say, yes, the water was coming by this way or receding. Is it an uprush deposit? Is it the backwash? It was impossible to have this, to retrieve this. So we began to do some peeling. You put glue on the sand here, and then put a textile on it. After one night, you come, you collect, and we try to work under a binocular, and it doesn't work very well. We can see some rough organization, but it is difficult. So the idea was to use a method used by geologists, but to apply this method to unconsolidated fresh sediment like sands. This was never used in this context. So the method is anisotropy of magnetic susceptibility. The name is a little bit complicated, but it works. It uses the natural characteristic magnetic properties of sands. Magnetic susceptibility is the measure of magnetic response of a material to an external magnetic field. So you take a sample of sand and you put it in a magnetic field, and the material will answer, producing an induced magnetic field, and you measure this magnetic field. So, yes, if we consider that the sand are evolving from some crystals at the beginning, and the shape of the crystals are the result of the friction in the water, in a river or in the sea. The long axis of the grain is the more resistant. So the shape will be like that, because the long axis is more resistant, so the long axis is here. The AMS technique is just able to retrieve this long axis because the main properties, magnetic properties, are linked to this long axis. So we can retrieve this axis in a formation. If we have a river after that, flowing and deposited sand, all the axes will be organized the same way, like pebbles we have seen just before. We use plastic boxes to plug the sediments, like that. And we use this apparatus to make the measurements and to retrieve the general organization of the long axis of the material. So you have the magnetic ellipsoid we produce with this induced magnetic field. And you can retrieve some very interesting data. First, on the direction of the water that have deposited the sand. So you can really say this is a layer of sand deposited by the water coming inland, an uprush, and this layer is due to the wave receding, so backwash deposit. This was not possible before that. Also, we can use some interesting parameter like T. It is a shape parameter, and when it is comprised between 0 and 1, you can see that decantation dominates. So settling is dominating. When compressed between between -1 and 0, lineation dominates. So you have a strong energy and shearing at the base of the water column. So you can also retrieve the processes in detail, all the processes of the emplacement of the material during a tsunami. the technique allow you to determine the orientation of the flow, allow you to determine sedimentation condition, decantation, traction, allow to reconstruct flow direction. So you sample all the tsunami deposit like that, and you can retrieve a lot of information. We reconstructed for Banda Aceh. I show you that there was the tsunami deposit for 2004, the rice field material, and then soil, and then again a tsunami deposit. And this tsunami deposit here is due to an old tsunami dated 4,200 years before. And we can reconstruct the number of the wave and the behavior of the wave. I will finish with work we have done in Agawa, near Sendai. We have a pond here near the shore. And we went there after the tsunami, 2011 tsunami, and we plugged the material here and then collected with these boxes the material from the core here. This was a picture of the core. You can see sandy material, clay, silt material, sandy material, silt material, sandy material, silt material. So this is the first strong energy event, the first tsunami, a second tsunami, a third, and a fourth. And this tsunami is the last tsunami. This is the last tsunami, the 2011 tsunami. And we have 3 other tsunami recorded. And you can see very easily here. And this tsunami at the base, we have 1 wave recorded, 2 wave recorded, 3 wave recorded. So you can reconstruct a very old tsunami. This one is dated 2,900 years before. And we know exactly how it behaves only because of the UMS technique. This was the first arriving of the wave. First tsunami at the base, then a receding here, because we have slope on the side of so the water climbed the slope and went back very quickly. And after that, all the water that arrived here went back after this water went back. The main backwash was coming by this way. And all these directions are recorded in the sediments, and we retrieve this only by UMS technique. The second tsunami, 2 waves with the same behavior. First, backwash, strong. Oh, sorry, no, it's false. This was first, and this was the last backwash. And after that, we have again another tsunami just before the last tsunami, 2011. So you can see that it's really a useful technique. UMS is a very useful technique, very recent. We use this since roughly 10 years. And we reconstructed a lot of interesting events all around the world now. And it's really easy to use, very costless. And yes, it can bring us a lot of interesting information, especially to reconstruct very old tsunami events. So for me, it's okay. If you have any question about all this talk or this presentation, I will be very happy to answer or to try to answer. and to bring you some, yes, some light on this fascinating science of reconstructing very old tsunami deposits.
All right, Patrick, are you finished?
Yes.
All right, thank you very much, Patrick, because a little bit connection disturbance before. It was very interesting. Thanks for your nice presentation, Patrick. Actually, it's very new for me. Try to understand the tsunami from the sediment.
Yes.
I also did the same thing. Try to understand the earthquake, but from the outcrop that I present in the Kobe before.
Yeah.
It was interesting, and yeah, but for us in Indonesia, it's very new method. So I hope it will be very lot of question here in this room to ask you something. All right. For the audience, monggo teman-teman semuanya, kita masih ada waktu paling tidak sebelum maghrib. Maghrib is sekitar jam 5.30-an, kita paling sudah harus finish. Jika ada pertanyaan bisa disampaikan segera, bisa menggunakan aktif mikrofon or bisa di chat. Monggo teman-teman semuanya, jika ada pertanyaan silahkan saja. I think Patrick also understand Indonesian language a little bit, so you can use sedikit. You can use Indonesian language to deliver your question. Monggo, ada pertanyaan?
I hope that my English was not. I tried to be clear, but sometimes I don't know if the message was really clear.
Yeah, I think it's clear enough for me, but I don't know from the others. Yeah.
Okay.
Because the connection and everything, yeah. Alright, ada pertanyaan teman-teman semuanya atau dari Bapak Ibu dosen yang hadir di sini? Any question, please? We'll check in the chat. There is no question. Okay. Maybe I can start to. I have some question, Patrick. Maybe yes. I can start to make everything also deliver the question. My question is, after we retrieve the information from sediment,
yes,
the tsunami information from sediment, can we use that data? I mean, all of the information, the magnitude, the flow direction, how many waves in particular area, can we use that data to make some like mitigation planning, or maybe evacuation planning, or maybe regional planning? Can you tell me how to do that? I mean, just share your experience regarding the data.
Yes, I think it would be very important to take this data in account, because sometimes you have recent tsunami. So we work on recent tsunami and say, okay, the water came from here and reached 2 kilometers inland. But if you look at all deposits, you can see that sometimes you have recorded more than 5 kilometers inland. So it's important to know that stronger, if you base only your planning on the last event, maybe you don't have something really real. Sometimes you can have more strong tsunami, and you need to take this in account when you do planning for evacuation, for instance, or this kind of stuff. It's important. Yes.
Okay, thanks. I saw Nico Pratama has raised the hand. Please, if you have some question, please active your microphone. Mas Nico Pratama, do you have some question? Mas Nico? Nope. Okay. All right, Bu.
Radit.
Oh yeah. Oh, Mas
Oh.
Rudi. Okay.
Okay,
Monggo.
I have any question.
Okay, Mas. Monggo.
Please
tell your name. Please
okay.
mention your name first, Mr. Rudi.
Okay, my name is Rudianto. I'm laboran. I will ask any relationship about sedimentary marine with geomorphological process.
Just this, Mr. Rudi.
Yeah. Yes.
Okay. Mr. Rudi asks Patrick, is there any relationship between the sedimentary with the marine process? I mean, the sedimentary in the marine with geomorphological process.
Yeah, I don't know exactly that. You know, when of course you can retrieve some information, some interesting information in the sea too, in the ocean too. When you work on tsunami, you have two possibilities. First, you know that the waves are coming from the sea and coming inland, so you can work on the deposit inland, like all the stuff I show you was inland. But after that, you have a receding of the water, and the water is eroding the soil ashore and will bring a lot of material from the land to the sea. And you can find a sedimentary signature due to the backwash in the ocean. And you can look and do some cores in the sea, and you can work on the sedimentary signature in the sea. So you will research, you will look for not marine sand inland, but for soil in the sea. You understand?
Yes, I understand. Thanks.
Mas Rudi, okay, that's good.
Ada hubungan Pak Adit.
Yeah, siap.
And in Japan, researchers are working in the sea. Sometimes they do coring because inland, sometimes the sedimentary signature is erased by the human activity.
Yes.
And so you know sometimes very well that a lot of tsunami occurred along the shore of Sendai, but in Sendai you can find only one single tsunami deposit, very old. That's it. And the four tsunami we found in the pond, we have a lot of change because it was just trapped in a pond, in the bottom of a pond. So no human activity there, and so you can retrieve the sediments. But if you are at the surface of the plain of Sendai, you can find nothing at all because of the agriculture, because of
people activities.
Yeah. So if you work in the sea, you have less disturbance, and the material is more preserved.
Alright, baik. Apakah ada pertanyaan lagi selain Mas Rudi? Monggo silakan dilempar saja pertanyaannya. Jika susah menggunakan bahasa Inggris, bisa menggunakan bahasa Indonesia. Nanti sebisa saya, I try my best to translate in English. Yeah. Ada pertanyaan teman-teman sekalian, Bapak Ibu dosen, mahasiswa yang ada di sini? Oke, let me ask you. Ya, silakan. Oke, belum ada.
Pak Adit.
Mbak, iya, Mas Rudi.
Saya lagi Pak Adit, boleh?
Sebentar Mas Rudi, ini ada Mbak Fitria Murnawi yang mengangkat tangan. Mbak Fitria?
Iya Pak.
Oke, silakan Mbak Fitria.
My name is Fitria Febri Murnawi, and I just curious about what the point of sign that indicated in their land is have a tsunami.
Ya, that's it, Mbak. Itu saja, Mbak Fitriani Murawi.
Yeah.
Okay, saya try to make your question become perfect. What is the key indicator inland that's the area already experienced by tsunami from the sedimentary recording?
It's hard. The idea, we know that sometimes you have a tectonic activity in some area, and so we suspect that by the past it could have been tsunami at this place. It's a geomorphological context and tectonical context. If you have also volcanoes in the area, you can have also tsunami produced by flank collapse entering in the sea. But sometimes you have no idea. We have worked in the Pacific Ocean, in the Tonga Island, where we have maybe the largest blocks brought from the sea to the land. It's 3 times higher than one man, so maybe around 5 meters in high, and you have 6, 7 meters in long, and it's a huge, huge block. It's called the Maui Rock, and it's the largest block removed from the sea to the land and deposited 200 meters inland by a tsunami, by a very strong tsunami. And we found on the coast of the main island of Tonga, the island is called Tongatapu. On this island, we found a lot of very huge stones, very huge blocks, 500 meters from the sea and 30 meters above the sea level. So you can imagine the incredible energy needed to bring all this material at such an altitude and such a distance from the sea. And we have the evidence of a ash deposit at top of the island. And this ash deposit is we can only find on the highest altitude. So maybe 1/10 of surface of the island. But everywhere we have no deposit of these ashes from a very strong volcanic eruption not far from here. This is due to this very strong tsunami that covered quite the totality of the island. And we have no idea. It cannot be a tectonic tsunami, because if we do some modeling, it's impossible to reach this altitude and to bring these blocks ashore. There is no volcanoes in these areas able to do this strong explosion and so produce so huge waves. So maybe it's a meteoritic impact in the ocean, but we have no real trace of this meteoritic impact. And it's very, very strange. We have here a very strong event, and all the work we have done attests this incredible energy, but we don't know where the waves come from. So if you want to work on tsunami deposit, you have first to look at the shape, the configuration of the seashore. You must have a strong stock of sediments along the shore, like sands, like beaches of sands, because this is material able to be mobilized by the water and brought inland to do a sedimentary signature. So after that, you have just to dig and to see if you can find some evidence. But we know along the southern coast of Indonesia, we know that probably we will find something, because we know that there is a trench here and we have a subduction zone, and probably we have evidence of tsunami.
All right. So you try to find that we need to choose the correct location to observe when we want to do a tsunami based on the sedimentary recording.
Yes.
Alright, Mbak Fitria, saya kira tadi jawaban Patrick. Ada yang ditanyakan lagi atau sudah cukup jelas?
Pak.
Oke. Ya, ada lagi. Tadi Mas Rudi ya, Mas Rudi monggo. Time is yours, Mas Rudi. Ada yang mau ditanyakan lagi?
Yang lain dulu Pak Adit, tapi kalau nggak ada nanti boleh saya lagi.
Siap, saya juga kepingin sebenarnya, Mas.
Oh iya.
Oke. Yang lain ada pertanyaan?
Saya Pak.
Iya, silakan Mbak Mauliza.
My name is Mauliza. Bahasa Indonesia aja ya Pak.
Monggo, silakan.
Saya mau tanya, apakah dari data sedimentasi dapat diketahui ketinggian tsunami yang pernah terjadi? Mungkin ini pertanyaannya ada beberapa hal yang tadi saya lewatkan, tapi saya akan bertanya ini. Dan satu lagi, jika bisa mengetahui ketinggian tsunami, seberapa akurat ketinggian tsunami yang dapat diketahui dari data sedimentasi? Terima kasih.
Yep. Yeah, thank you, Mbak Liza. Patrick, are you understand? Or
I'm not sure.
Okay.
A little bit, some words, yes.
Okay.
But
Mauliza asks you that can we know the height of tsunami, the past tsunami from the sedimentary recording, and also if we can, how accurate the sedimentary record can show the height of tsunami?
For the moment, if we have the evidence of a paleo tsunami, an old tsunami, along the seashore, near shore, we need to go inland and to dig just to find where the limit, where is the limit of this old tsunami. We have from the sediments, we don't know, we can know the velocity of the water, but we cannot know about the height reached by the water. It's not so evident. In the Tonga Island, we have worked on these blocks, and it was not sure that these blocks were coming from the sea. It was in coral pieces of coral, but it's coral limestone, but we were not sure that these blocks were brought by tsunami. But when we dig under the blocks, we found marine sands with foraminifera, and these small foraminifera attest that yes, the material was coming and this marine material was trapped under the blocks. So this is, the blocks came with the tsunami and the foraminifera too. But otherwise, we don't know exactly. We cannot just from the sediments know the height reached by the tsunami.
All right. So how we can know the height of the tsunami that you said before in Aceh there is 15 meters?
In Aceh, yes, because in Aceh we went just after the event, and then we worked on the trees. We worked on the vegetation completely erased by the water, and also from the vegetation killed by the salt on the slopes. And we had when the water during the tsunami in 2004 in Banda Aceh, on the southern coast of Banda Aceh in the city of Lombok, we had there a small hill, and at top of the hill we had a tree tilted by the water, and atop in the branches we have palm branches trapped in the branches of the tree. And this was due to the height of the water, because the branch of the palm was floating on the water and was trapped by the branches. So we know very well that the water reached this place. Sometimes you have geomorphological evidence when you have strong erosion, and sometimes we have other evidence.
All right. So it's not enough from the sedimentary to know the height. We need to another data, to know to reconstruct the tsunami height. Yeah.
Yes, yes.
Oke, Mbak Mauliza, saya kira sudah terjawab.
Ya, Pak.
Ya. Ada pertanyaan yang lain dari audiens? Sambil diisi absensi linknya ya, tolong diisi link absensinya untuk keperluan sertifikat nantinya. Jadi akan kami kirim sertifikat ke alamat email yang kalian isikan pada link absensi. Alright, any other question, please?
Mas Aditya?
Yeah, Patrick.
Yeah, I can probably send you. I have just to check, but I removed some picture from my presentation, so I can send you the presentation if some students want to read it again and have more ideas about that. I can do that.
All right.
Without any problem.
Okay, thank you very much, Patrick.
Oh, you're welcome.
All right. Any other question? Jika tidak ada, saya berikan ke Mas Rudi untuk bertanya. Bu Vidya mau bertanya? Mengaktifkan video? Tidak. Okay. Any question, please? Kapan lagi kita ngomong dengan tsunami sedimen ya? Dia ahli pawangnya tsunami sedimen. Nah, gitu.
Yeah,
ternyata sedimenta kelut. Ya, silahkan.
Pak Adit.
Monggo Mas Rudi, monggo Mas.
Oh belum. Oh ya, saya tunggu. Silakan nanti kalau ada yang lain, kalau belum.
Monggo silakan Mas. Ini sepertinya
gitu.
tidak ada yang lain. Belum ada ya, belum ada. Sebentar Mas Rudi, sebentar Mas, ada Mbak Esti nih.
Oh iya silakan.
Ada Mbak Esti Kurnia Ningsih, silakan karena raise hand.
Yeah, I want to ask a question to Mr. Wassmer. My question is, what do you think about the potential of tsunami in Java Island? Does it similar to Banda Aceh? Yeah, that's it.
All right. Monggo, please,
Thank you for your question. Yes, I think we are in the same context along Java Island, in the same context as Banda Aceh. So you have this confrontation between two tectonic plates, and you have a subduction zone. So yes, probably we can have a tsunami, a strong tsunami, like in Banda Aceh. We have in 2006 a tsunami along this coast, and this was rather strong, and there was a lot of people killed, especially in Pajanjaran. Pagandaran.
Pajajaran is correct.
Pajajaran, yes, it's correct. Okay.
Sorry, Pangandaran. You mean Pangandaran?
Pagandaran, Pagandaran. Yeah. And yes, we have some. It's hard. We have worked all along the coast of Java, but we cannot find really good evidence of old tsunami. We have some signs. I have worked in parallel with a guy from the USGS in United States, a very, very brilliant researcher, Brian Atwater, and he told me the same. He worked along the coast there and didn't find very good evidence. We have a lot of, in some place, we have some mangroves. Sometimes in the mangroves, it's hard to find something because you have all the what do you say, capeting, yes, working and removing all the first 40 centimeters of mud or of sand, and you cannot find evidence of. If you have a muddy coast, if you have mud on mud, you cannot decide if this is a tsunami deposit and this is not. So sometimes it's really hard to do. And so for the moment, we have no real evidence of very old tsunami along this coast. In Banda Aceh, we have some context more interesting near Banda Aceh, maybe 30 kilometers south of Banda Aceh along the coast going to Malabo. You have a cave. Maybe you heard about that. And the team from the University of Banda Aceh and from the University of Singapore, they work in a cave and found evidence because you have in the cave sediments and you have very dark layer delimiting the or separating the sandy sediments. And you have a lot of bats in the cave. So when you have a tsunami, the water bring some sand. The sand is wrestling in the cave. And so after that, you have the bat activity and you have a layer fossilizing the sand. And after that, another tsunami. And after that, bats activity, another tsunami, and so on. And they found 11 deposits. And they tried to reconstruct the history of tsunami along this coast during the 5,000 last years. And it's really impressive. But for me, I don't know how it was possible, but this paper was published by Nature. Of course, it's astonishing. It's really brilliant. But the entrance of the cave is 1 meter above the sea level, 1 meter above the sea level. So how to, and in the paper, the people said, there is no storm along this coast. So we can say that all the sandy material from the sea in the cave is coming from tsunami. This is not possible. You know, if you look just at the recordings of the storms in Banda Aceh and the height reached by the wave is more than 4 meters, sometimes 5 meters. And the people say, we have only tsunami deposit. I'm not okay with that. It's not possible.
Yeah.
So,
yeah.
But the context in the cave is so incredible because nobody removes the material and it's really, really interesting.
Yeah.
But I will go there just to be sure and to redo the same study on the deposit with the AMS and try to find if it is only tsunami or not.
Don't forget to tag us.
Yes. And now we have a project. Now we have a project with Pafranc and Raphaël Paris from the University of Clermont-Ferrand. And we have a project to investigate this area again, maybe in October or November. But I will tell you about that, and I will. Yeah.
Thank you. Oke, next Mbak Hesti sudah ya, sudah terjawab ya. Jadi sangat sulit untuk tadi pertanyaan awal tidak ditemukan evidence paleo tsunami ya di Java.
Iya.
Berbeda dengan yang di Aceh.
Ya Pak Aditya, begini. Karena kemarin saya membaca berita itu BMKG mengumumkan tentang potensi tsunami di daerah Cilacap.
Oke.
Untuk beberapa tahun ke depan, tapi belum bisa diprediksi. Hanya itu.
So Hesti add some information that BMKG and the Meteorological Agency of Indonesia
Yes.
predict that there is a high tsunami, a potential high tsunami in the southern part of Java.
Yes, this is probably true because Cilacap is really exposed to tsunami too.
Yeah.
And in 2006, there was this event affect Cilacap too. And, you know, if you work in tectonic, the zone between the two plates are not moving at the same time, at the same velocity. And you are you know that the plate from the south is pushing to the north around 5 centi every year.
Yeah.
But nothing is moving at the zone where you have strong friction, nothing is moving. And so this pressure is accumulating during maybe 10 of years, during maybe 100 years, you have an accumulation of the tension here, and suddenly it moves.
Yeah.
Only some meters, but it's enough to give a very strong energy.
Yeah.
But if you consider all along the coast of Java, nothing is working at the same spin as velocity,
Yes.
you know?
Yes.
And sometimes you have a zone that do not move. It moves here, it moves there, but not here. And you know, the more the time is passing, the more the energy accumulated will be strong. And the more we can expect something very strong. It is the same for Sumatra, near Padang or near Bengkulu. Yeah.
Yeah, it's about the seismic gaps. Yeah. We have accumulated energy that sometimes we can release in earthquake and tsunami.
Yeah, sure.
Yeah. Gitu Mbak Hesti. Oke. Next mungkin beberapa pertanyaan lagi.
Thank you so much for explaining, and merci.
Merci. I am not sure it was enough clear for you, but I will send you my presentation, and I hope it will.
I really appreciate it.
Yeah.
Merci.
So, merci is like thank you, right?
Yes.
Okay.
Terima kasih.
Terima kasih. Matur suwun ya.
Ya.
Oke, next mungkin 2 atau 3 pertanyaan lagi karena mendekati maghrib. We are having praying after night praying soon, maghrib prayer soon. So maybe
I understand.
Maybe 3 or 2 question. Mas next ada Mas Ubaidillah. Karena raise hand, monggo silakan Mas Ubaidillah. Ada any question, please?
Thank you. Terima kasih.
Suaranya kecil sekali Mas Ubaidillah Rosid. Bisa dikeraskan.
Sudah bisa didengar?
Ya, sudah.
Sudah ya. Oke. Thank you, Mr. Patrick. If the presentation that have been presented, you explain about what is the tsunami disaster can affect or influence the shape of the physical or of land, or they can affect geomorphologically. But I want to ask about to see this case from the other side. To see this case about from the other side or the other perspective. As far as you observe, can be the deposit of the sedimentation give some advantage or maybe some loss or disadvantage in the shore existence about the ecosystem maybe and the others. Maybe my question is a little bit out of topic, but I think it's not a problem. That's all from me.
Okay.
Thank you.
Okay, thank you. Are you understand, Patrick, or you need me?
Yes, the sound was very loud, and I cannot very. I miss some words. The idea, I think, it's what is the consequences of a tsunami inland and on the not only on the morphology but on the ecosystems.
Yeah, I mean the tsunami. They mean the tsunami deposit. What's the effect of tsunami deposit to the ecosystem? I think.
Yeah, yeah. This is interesting because this was for us. We imagined that after the tsunami in 2004, because we have a lot of sand on all a blanket of sand of all the landscape around Banda Aceh, we imagine that the human catastrophe will be then an ecological catastrophe. And it was not the case. And we were very surprised to see how quickly the vegetation recovers on this area, mainly because of some plants very active to cover the sand, and especially this I don't know the name in Indonesia, but the Latin name is Ipomea. I don't know if you know these plants that are doing some stems ramping on the ground very quickly, doing a network of branches on the soil and covering and fixing the sand. And after that, when the sand is fixed and the rain has washed the first centimeters of soil of sand from the salt, then immediately you have a lot of plants growing. And after 1 year, you cannot see that there was a tsunami here. And after 5 years in Banda Aceh, we had trees 15 meters in height, and it was incredible. We never imagined, we imagined that the salt will be killed all the vegetation, but it was at the rainy season. And so maybe the rainy season and a lot of waters poured during the rains washed the sediments and then allowed the vegetation to recover very quickly. What is interesting for us too was we work at the south of the Krakatau volcano in the Sunda Strait. And here, if you come from the strait going to Laban Isthmus, I don't know if you see, because you have the end of Java Island and you have the Ujung Kulon Peninsula, and between the two you have a strip, a piece of land, a narrow piece of land. It's an isthmus, and on this isthmus, when you come from the sea of the strait, you can see that the vegetation, all the vegetation is at the same level, same aged, like if all the trees have grow together. If in a natural forest, you have different height between the trees. Here, on this strip of land, you have all the vegetation is the same height. And this is due to the fact that the tsunami completely washed out, shaved out to the ground all the trees of the forest, and the water poured to the Indian Ocean through this band, this narrow piece of land. It's not 2 kilometers, maybe 1 kilometer and 700 kilometers. Yes, meters, sorry. So the water came from the strait, crossed this Laban Isthmus, and poured in the Indian Ocean and erased all the forest. And after that, the vegetation recovered, all the trees together, and that you have the top of the vegetation is completely flat. This is interesting and showing how the vegetation recovers after a tsunami.
Yeah, I think it's more about the vegetation and the impact of the sediment of tsunami. we have also the same problem with the sand dune in Parangtritis. In
Yeah.
the dry season is very dry, but in the wet season the vegetation is very dense over there,
Yeah,
and
yeah.
disturbing the aeolian process of sand dunes.
Yeah, but here in on this Laban Isthmus, you have locally more than 3 meters of tsunami deposit.
Ya.
Yeah.
Oke, Mas Ubaidillah, seperti itu sepertinya jawabannya.
Ya.
Oke, ada yang ditanyakan lagi?
So if I try to conclude the tsunami disaster can be advantage from the existence of ecosystem, right?
Ya, Patrick.
Yes, so if I understand very well, the sound is I cannot understand all, but
yeah, is it a positive effect of tsunami? Is the tsunami has a positive effect on the vegetation?
I'm not. I don't know if we can say that, but we used as I work on this natural disaster, but on the other side, I work and I teach also biogeography and all these ecological environments. And for me, it's not something positive or negative. It's restarting. You in some area you start for nothing, but you have a lot of seeds. Of course, you have a lot of roots already still rooted deep in the soil that allows the vegetation to recover very quickly. This is sure, but is it really positive? I don't know if we can say that. In some case, we have seen huge storms in my environment here. We have mountains and we have forest, a lot of forest. And in 1099, we have a very, very strong storm. And in some area, maybe a third or half the cover of the vegetation was on the ground. And this was really a positive starting for a new vegetation and a more, we had not too much biodiversity in this old forest. And after that, we have an increasing, very, very strong increasing of the biodiversity. I'm not sure that in the case of the tsunami, it's the same. I think it's the same plants that are able to grow after this this event. Yeah, it's not so different, I think.
Thank you, Patrick. I think.
Okay, thank you, Mr.
Yeah, thank you, Patrick. I think that's all because we almost pray, unfortunately. Okay. So I will have some closing statement for our discussion to afternoon. So far, the tsunami sediment tell us a lot of things, a lot of useful information.
Yes.
Maybe it's like a time machine to the past. What happened in the past, especially in tsunami. So maybe for students, we always study about the key of geomorphology. The present is the key to the past. Maybe this is a good example how to implement that concept. So we study about the present, about the sedimentary of tsunami, and try to understand the process, try to understand what happened tsunami in the past. And after that, we can to reconstruct the better environment, which is life peaceful with the disaster, I think. Yeah, I think that's all, Patrick. Thank you very much for joining us today.
Thank you all. Terima kasih.
Terima kasih.
Sampai jumpa lagi.
Sampai jumpa lagi. See you next event. So we are pleasure have you here. I think I will give the time back to the Bu Vidya. Waktu dan tempat saya kembalikan ke Bu Vidya sebagai MC. Dari saya, jika ada salahnya, saya mohon maaf sebesar-besarnya. If I have mistake, I'm really apologize to all of you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you for Dr. Aditya Saputra for guiding us in the lecture section. All right, participants, ladies and gentlemen, I think we've had a productive and inspiring time together, and we finally come to the last agenda of this lecture. I hope you all found the presentation of this lecture is informative and helpful, like me, and hopefully this will bring benefits to our work in the future. Last but not least, thank you to the all audience for your active participation. And on behalf of the committee, I'd like to thank the speaker, Patrick, for the valuable and informative lecture. Thank you, Patrick. Again, thank you for joining us today. And all right, see you again in the next session, in the next event. Saya tutup.
Ibu, mohon maaf Ibu Vidya, sebelum ditutup kita adakan sesi foto bersama dulu. Ada 3 layers, ada 3 halaman. Mohon diaktifkan videonya jika bisa. We have a photo session first, Patrick, before closing as evidence of activities.
Okay, all right.
Okay. Just put your very cute smile, and I will take a screenshot photograph. Ini saya tidak tahu kalian di halaman mana, jadi mohon tetap senyum ya selama saya memotret 1 halaman per halaman ya. Oke, saya akan potret halaman pertama. 1, 2, 3. Kemudian saya beralih ke halaman kedua. Mohon tetap senyum dan tetap aktifkan video. Dan last page. Oke, Bu Vidya, saya kembalikan waktunya.
Okay, thank you very much for all of you. I think we can close this session. Saya tutup. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. See you, Patrick. Thank you very much.
See you. You're welcome.
Bu Vidya, saya nanti minta recordnya ya.
Oh ya Pak.
Yang record di komputer Bu Vidya ya.
Oke.
Kalau besar, saya ketemu langsung aja besok.
Iya Pak, coba saya lihat.
Iya, nanti saya dikontak ya. Oke, makasih Bu Vidya ya.
Oke Pak, sami-sami.
Ya.